Okay, I'm going to go through the multiple choice questions for test A. This is the practice test that I passed out in class yesterday, Monday, September 29th. Okay, question 1. Which of the variables would be quantitative? So A, freshman, sophomore, junior, senior, that's categorical. Okay, you could have counts of freshmen. You could have, say, 300 freshmen and 250 sophomores and 275 juniors and maybe 310 seniors. Okay, these would be counts. These don't have units. Only the units are simply the categories that they're in. Okay, so class is categorical, so it's not quantitative. B, grade point average. Okay, grade point average is quantitative. So this is A, not quantitative. B, grade point average is quantitative. And it has the units, which is, percent, I guess. C, whether the student is in AP class, AP yes or no. That's categorical. The category being AP or not AP. D, whether the student has taken the SAT. Again, your SAT or not SAT, those are categories. E, none of these. Well, the answer is B, grade point average. Okay, 2, which of these variables would follow a normal model? So let's look at 2. Well, family income, most of the incomes would be down at the lower end. Let's say here's income going from 0 to billions. Okay, so most of the people would be down closer to the low end, and then there'd be a few people making a lot of money. So this is not normal. Skewed right to the higher numbers. Okay, skewed to the higher numbers. So it's not a normal distribution. B. So this is A. B. Heights in a co-ed choir. Okay, so what would that look like? Okay, so let's say height. Here's 0 height, and here's 10 feet, or whatever. Okay, so you would have 2 modes, probably. Something like this. Not quite that extreme. This mode would most likely be the females, who tend to be somewhat shorter, not as short as I'm showing here. And this would be males. Okay, so you really have, when you show 2 modes, you're going to have 2 populations. So this one has a center right around here, and this one has a center right around here. So not normal. Normal means, among other things, as a minimum, bell-shaped and symmetric. Okay, C, weights of adult male elephants. Now here we have a population that is restricted. Elephants, adult males. Okay, this is most likely, of all of these, to be unimodal and symmetric and possibly normal. Scores on an easy test. Okay, what is that going to look like? Well, here's 0 and here's 100. And you're going to have a whole lot of people with 100s and a few people with low scores. Skewed left. Skewed to the lower numbers. Skewed left. Towards the lower numbers. Okay. And all of these. Well, we've already shown that there's family income, heights in co-ed choir, and scores in an easy test are not normal. The only one that's normal is weights of adult male elephants, so that's the right answer. Okay. 3. Professor keeps records on grades they've earned in his class. If he wants to examine the percentage of students earning the grades A, B, C, and D, and F during the most recent terms, which kind of plot would he make? Well, a box plot, first of all, this is categorical data. A, B, C, D, and F are categories of grades. Even though they could be shown as a histogram, in other words, with bins, like with the breakdown of grades. Nevertheless, in this situation, they're categories. We don't know what makes a grade A, B, C, D, or F. Okay. So what would he make? A box plot is for quantitative data. A time plot is for quantitative data. And a histogram is for quantitative data. Only a pie chart is for categorical data, and it would show the percentages. Okay? None of these other plots show percentages. They show quantity, they show numbers with units. Okay? The pie chart is showing percentages. Okay. 4. So I didn't really draw anything for 4. For 3, I said 4. What is true of the data in the histogram? The distribution is approximately symmetric. Well, that's definitely true. The mean and the median are approximately equal. That's true. Now, the next statement is arguable. The median and IQR summarize the data better than the mean and standard deviation. Well, I don't know. You could argue one way or the other. The answer in the book is that the mean and standard deviation are the best summary of the data, summarize the distribution. So the answer is just 1 and 2, which is C. But you could argue that the distribution is definitely not normal. It does not. It has a shape that is not bell-shaped and symmetric. It is symmetric, but it's triangular. It's not bell-shaped. So in that sense, it's maybe not such a great candidate for summarizing with the mean and standard deviation. But there'll be more on that later. Okay, 5. 2 sections took the same quiz. One had 15 students, the other one had 20. And Section A had a mean of 80, and Section B had a mean of 90. What was the approximate mean score for all the students? Well, in order to answer this, you have to weigh your averages. All that means is you're going to do 15. You have 15 students with an 80, and you had 20 students with a 90. So we take 15 times 80 plus 20 times 90 and divide that total by 35, and you get the right answer, which is 85.7. Okay. 6. Your stats teacher tells you your score was on the 3rd quartile for the class, which is true. Okay? Well, let's draw a picture. Let's draw a box plot. Okay, let's say here it is. Looks like this. And here's Q3. Now, Q3 has nothing to do with whatever your grade is. Okay, everybody in the class could have gotten a 75%. Everybody in the class could have gotten 100%. Everybody in the class could have gotten 0 on the test. Okay, Q3 has to do with the 75th percentile. 75% did poorer than Q3, 25% did better. It doesn't tell you anything about what the actual data is. Okay, so number 1 is wrong. Doesn't tell you got 75% on the test. It's the 75th percentile. Okay, not that you got a 75 on the test. Doesn't mean that this guy got a 0 and this guy got 100 and this guy got a 50% and this guy got a 25%. No, what it means, Q3, 75th percentile means, the third quartile means 25% of the students did better than you and 75% did worse. Okay, that's it. Okay, 2. You can't really tell what this means without knowing the standard deviation. The standard deviation has nothing to do with quartiles. Quartiles are computed using the median. Okay, and counting the data, the quantity of the data. It has nothing to do with the standard deviation, which is based on the mean. The mean has nothing to do with quartiles. 3. You can't really tell what this means unless the class distribution is nearly normal. You do not need a normal distribution in order to use quartiles. Regardless of the distribution, you can always use quartiles. Every distribution has quartiles. You put the data in order from smallest to largest and start counting. And the first quarter of the data is the 25th percentile. The first half is the 50th. The first 3 quarters is the third quartile. And at the end, you got the max. Okay. So you don't need a normal distribution in order to have quartiles. You can every distribution of quantitative data has quartiles. All right. 7. Suppose that a normal model described student scores in a history class. Parker has a standardized score, a z-score of plus 2.5. This means that Parker is 2.5 points above average for the class. Standardized z-scores have no units. Okay, so it tells you nothing about the score on the test. You could have a z-score of plus 2.5 and have gotten a 50% on the test. What that means is everybody else practically got lower than 50% on the test. Okay, so doesn't tell you anything about the distribution of the scores themselves. It tells you about where you stand in relation to everybody else. Okay, now the z-score is a measurement of standard deviations, and that's B. Is 2.4 standard deviations above average for the class? That's exactly right, because the average is the mean. So B is the correct answer. C has a standard deviation of 2.5. No. The z-score is not the standard deviation. Remember, z equals y minus mu over sigma. It's a count of standard deviations. You take the distance, the count. Take the distance between your data value of interest. Okay, so here's mu, and here's the y that you're interested in. You take the difference between them, that's the distance, and then you divide it by the standard deviation, and that tells you how many standard deviations are between the mean and your data value of interest. So z is a count of standard deviations. It is not the standard deviation. The z is calculated using the standard deviation right here. So you take the difference between the data value that you're interested in, the distance between the mean and the data value that you're interested in, divide by the standard deviation, which is the yardstick, and that tells you your z-score. In other words, the count of standard deviations. Okay, it has a score that is 2.5 times above the average for the class. No, it's not a multiplier. It's a measurement of standard deviations. None of the above. Well, no, that's not true either, because B is correct. 8. The advantage of making a stem and leaf display instead of a dot plot is that a stem and leaf display, A, satisfies the area principle. Well, the area principle applies to bar charts and pie charts, which are used for categorical data, not quantitative. So A is wrong. B, shows the shape of the distribution better than a dot plot. That's arguable that as being true. Okay, a dot plot has gaps everywhere, and unless you have a real lot of dots, it's hard to see what the distribution is exactly. Whereas stem and leaf, I think, is a little bit better at showing the shape of the distribution. But that's not the right answer. The right answer in the book is C, preserves individual data values. Now, you could also argue that a dot plot does preserve the individual data values. It doesn't tell you what they are exactly. You have to infer them from the number line underneath the dot plot. Whereas the stem and leaf display does tell you exactly what the data values are. But still, the dot plot comes close. A lot closer than a histogram, for instance. D, a stem and leaf displays for quantitative data while a dot plot shows categorical. That's false. They are neither of them. They're categorical. They're both for quantitative. So I would take B or C for this, and I need to give you a little bit more discussion on this. Okay, number 9. Which statement is true? There are no outliers. So what are you going to do? You're going to measure the outlier fences for 9. Okay? The right-hand fence equals Q3 plus 1.5 times the IQR. So the IQR is Q3 minus Q1, which is 18 minus 15, which is 3. 1.5 times 3 is 4.5. So the right-hand fence equals 18 plus 4.5, which is 22.5. So the right-hand fence goes beyond the max of 22, so there are no right-hand outliers. And the left-hand fence equals Q1 minus 1.5 times the IQR, which is going to equal 15 minus 4.5, which is 10.5, which is less than the minimum. So there are no outliers. The minimum is greater than the left-hand fence, and the maximum is less than the right-hand fence. There are no outliers. So the right answer is A. And 10. Which of the following summaries are changed by adding a constant to each data value? Okay. Measures of center are affected by changed by plus, minus, multiplication, and division. Measures of spread only by multiplication or division. Now, measures of center and position, like min, max, Q1, Q3, those are measures of position. Those are also affected by all 4 operations. The measures of spread, which are the median and the standard deviation, are only affected by multiplication or division. Okay, so that's it for the multiple choice questions. I'm going to stop here, and we will continue today on the